The title of this presentation is a comparative study of interfacial transition zone in the geopolymer and the Portland cement concrete. We use the modeled interface. Like Dr. Wengui unfortunately cannot be here, so therefore I just present for him. Here is the outline. You can see we'll just introduce the modeled interface for you. And then we characterize all of this interface using the SEM, ITZs, and Nanoindentation and Nanoscratch. Then we just discuss about what's the complicated nature of interfacial transition zone. Then here is a natural one. If you have aggregate, you have interfacial transition zone, then you have cement paste. Also, people already did a nanoindentation with the mapping and have probably. What we did is have the piece of aggregate. Actually, this is a limestone aggregate. Then we polish the surface and we embed this aggregate inside of the paste. The paste can be the geopolymer and or the Portland cement paste as the comparison. Then you cut through the with that you will have the sample with the paste and the clearly interfacial change, interface and aggregate. Then we use the nano indentation and the Nanoscratch. And the next, we also want to see what is formed between the aggregate and the cement paste. So we have aggregate the disc, and we put the plastic tube. Then we has put the paste on the top. Then we can just use the hand to separate them and look at the surface on the interface on the aggregate. Also can look at the interface on the paste matrix. So let's use the general SEM analysis. Now I'm going to show you some results. As I said, we have the second model. We separated that. You can see something on here. That is the aggregate. This is the residue of the geopolymer over there. Then here for the geopolymer, they have very good bond. Then you see lots of the residues. But for the interface between the aggregate and Portland cement paste, they have very limited residue adhere on the surface. Then you can see also here is what we observed from the residue of the geopolymer on the aggregate. You can see because this is the flash-based geopolymer, you still see flash particles, and you also see some defects. And these defects will affect the nanoindentation results. And you will see unhydrated flash, and you have also see very dense gels. So this gives you the idea is inhomogeneity of this interface. Then we open that also for the Portland cement paste. You can see this is the pictures of the residues on the aggregate surface. So you see lots of crystals there. Some of that is the calcium hydroxide. Some of that is anthracite. And on the other hand, you can see we separate both. One is on the aggregate, on another surface on the cement matrix. This is on the right hand. You can see lots of bigger crystal because interface usually have poor high porosity. The crystal will easy to grow there. So you can see crystals and you know that have lots of space between them. Then for this interface, because the interface is very clear with this modeled concrete, then we did all of this analysis along the interface from the interface distance regulated to go further. Then you can see here this is the porosity. Then for cement and aggregate, Portland cement and aggregate, the interface, you can see high porosity, but for the geopolymer, the aggregate interface, the porosity is much lower. And if you look at because we know they have the wall effect, then usually at the interface, your solidity is less compared to the bulk material. Then you can see over here, for Portland cement, even less, and for the geopolymer, relatively have more. So that gives you an idea the geopolymer have better bond with the aggregate. Then here is the ITZs analysis, and just want to show for both of that, you will see the major, especially for the geopolymer, you see the major the components on the in the interface. This is silica, alumina, and calcium you won't see on this. Most of calcium you see on the aggregate because it's non-slump. But when you look at this interface, you see the difference. You clearly see they have the interfacial transition zone. And when we do the nanoindentation mapping, you can see this difference, and mapping the spots have the nanoindentation measured. And we also do the another Nanoscratch. We were talking about that later. But here on the top is the geopolymer. The geopolymer, the silica to the sodium ratio is the 1.5. You can see over here, then if we do look at the hardness and modulus, you can see here is the interface, here is it. Here is the interface, here is the cement paste. So interface actually have the better property. Then for cement paste, here is the interface, and they're just for that spot we are showing they're pretty close. Then we have the average, then you can see the modulus for interface for geopolymer, GP, then that is ratio is high than the Portland cement paste. For hardness also, for geopolymer, the hardness of ratio between the interface and the paste is also high. So that tells you the bond between the geopolymer and aggregate have the better bond compared to the Portland cement and aggregate. And here is we tried to do Nanoscratch. Then we did also look at this interface from the backscatter image. Then you also see the small amount of difference between the porosity. We did the Nanoscratch. You use the nanoindentator. Instead, you do point by point. You just go through the line. Then we did through the aggregate, then vertically perpendicular to interface, aggregate, interfacial transition, and paste. And we also did the scratch, perpendicular to interface. And here is just some results. Then real analysis is in the next slide. Here you can see when you put a different force, then you have slightly different results here, showing the different results over here. They add different load when you do the scratch. And here is show you the difference. If you have geopolymer, then your silica to the sodium ratio is different. Then you will have slightly different results. And this is the difference between both are geopolymer, same material, but different the silica ratio. The next one, just want to show you some difference with the value into the H is hardness and COF is the coefficient of friction. That you can see with different for geopolymer with different modular like silica to the sodium ratio, then cement paste and interface is different. And they have some of the this when we do the scratch parallel to the interface, then here is the results. Then on your left, that is hardness. Then you can see aggregates have slightly high, then, and the interface have slightly low. You can see, especially when you close to the aggregate, then they have some inhomogeneity. Some of that you are not see very like as a kind of the range is very close. Some of the place is very low value. Some of that is good. So and also for the friction of coefficient over here, you can see some of high. And you can model that distribution with 3 components and 5 components. Then if we put all of the data together, then we plot the friction coefficient versus hardness. You can see this kind of trend. They are not like a directly perpendicular, directly linearly related. Actually, they are kind of is indirect linear relationship. Because the hardness mainly is related to the composition of your in your interface, while the friction is related to the topology of your material. So that's you don't have a direct relationship. Then we look at the hardness, the summarize like based on what we already see. Then we have the modeled interface with different surface. Like you have bottom interface, you have top interface, you have side interface, and the results getting is different. So this is we want to show you here. Then that's both like from the SEM image and from the Nanoscratch nanoindentation. Then from the microstructure distribution, you can see here shows you top, bottom, and right side the same technology, same sample, then you have different results. For both from the SEM analysis and from the Nanoscratch results. And the Nanoscratch results also shows your different distribution. Some of the distribution is not really a normal distribution, and based on that, we said that when you study the interface, you may have different stages to go. So we are actually using the model, the interface, maybe just level 1, because you are kind of assume your interface is perfect. It's easy for you to look for the hydration products and the interface characteristics. But in real situation, you need to study for all of all different sides. That is level 2. We only study for level 1. And level 3 is a real concrete. You have all different kind of interface, and you should study. Then you have lots of complicated interface. This is a real one. And we also say maybe it's a good idea to use the SEM first. Then you can know what's the proportion or the range of different phases. Then you also can use the Nanoscratch, gives you the idea about the mechanical property of the interface, the gel, and other things. And the nanoindentation to put into the key area. Then you overall use all of this combined, you will have a good idea what's the unit, like the feature of your interface. So that is very quickly introduce the work actually majorly done by Dr. Wengui. So thank you very much. I hope this.